Yeah, okay, so I will start the main bulk of the workshop then, as long as our first speaker is ready. So our first speaker is Lourdes Verdes Montenegro from the IAA in Granada. So she's worked in terms of science, mainly on galactic evolution and nature versus nurture type of questions and that sort of thing. But a huge part of her research has been how is astronomy actually carried out, and how we need to document that so that people can actually reproduce it later. So she's going to tell us a lot about why open science, the problem of provenance and citation. So I'll now hand over to Lotus. You can begin whenever you're ready.
Thank you very much. So let me share my presentation. I hope you can see it now. And well, thank you very much for this possibility to speak about something that has become a very central part of my research in terms of practical terms, but also philosophical terms, because I found it key in different moments of my career from different points of view. So I'm going to talk today about why open science, why reproducibility, and the reason why I'm here, like Peter said, well, relates with my career in astronomy. I have worked always in the galaxy interaction, and trying to understand them. Can you see it well?
Yes.
Okay, there are no complaints. I'll assume this is okay. Okay, so since I started my research, I used different wavelengths and large samples, and all of this took me to try to find efficient ways to search for the data, but also to share my research. I also found the problem that I sometimes couldn't reproduce what I had done some months ago. And I thought that this could be the problem of different people, not only me. And I also worry about whether I was publishing the whole story of my research or just my main ideas and nothing else. So at some point later, I was the chair for the European Research Council panel for Universe, for the evaluation of starting grants. And speaking with the people there in Brussels, they told me that maybe my criticism about the way I could see some people wanted to evaluate CVs might be put in a talk to the people organizing committees at the ERC. And then I entitled the talk Law for Science or Academic Prostitution. And I had to say that the word prostitution doesn't come from me, but from this spatial nature in 2010. My talk was in 2013. That said that the research reverts to a kind of academic prostitution in which work is done to please editors and referees, rather than to further knowledge. So when speaking with these people at the ERC, we said, okay, that's nice because you do things for love or you do things for money or for rewards. And that's why I put that name to the talk. And what you are going to see here is obviously a very big evolution of what I presented there. And some things still are there because I think they are still valuable. What happened later is that I became the coordinator of the participation of Spain in the Square Kilometer array. And so I found a very good way to channel my concerns through what was going to be the largest generator of public data in the world. And then I propose SKA to organize a session at ESOF, at the European Open Science or the Euroscience Open Forum. In 2018, SKA was positive about this proposal, and we set up a panel to discuss about the metrics of science nowadays, and how are we going to handle that in face of the data deluge that was coming. So, well, that's why I'm here today. And things I would try to tell is about whether open science is a new concept, how the combination of metrics and economy lead to this sort of academic prostitution, tools that we have in our hands to do our science reproducible and to follow open science practices, but also whether it's possible to do big data science without open science. And I will try to finish with some revision of the research assessments as the policymakers are considering them now, and also the community is proposing, and the impact of following these best practices. So first point is that we are using, you probably realize that we are using many adjectives for science, excellent, we speak about the quality, trustable, open, but at the end, open science is at the very core of the scientific method and reproducibility. So this is a fundamental principle of the scientific method, and this was already pioneered 1,000 years ago by Ibn al-Haytham, if I pronounce it well. And he already proposed the idea that what we do should be confirmed, be able to be confirmed, and made this emphasis on reproducibility. But just in case we forgot about that, like 400 years ago, René Descartes reminded us, and by formalizing the foundation of the philosophy of science. And then what the main message here is that science means following the scientific method, so everything should be identical. Because we are scientists, I understand that we follow, or we want to follow, the scientific method. That's obvious. Then what's happening, because we know about the reproducibility crisis, and there was this survey on the community in 2016, asking what level of reproducibility could achieve researchers, and it happened that not only 70% of the people queried couldn't reproduce the experiments of other scientists. They couldn't even reproduce their own ones in 50% of them, and this number being the same for the different disciplines of the same level. And maybe some of you would say that you don't feel empathy about this idea because you feel that what you do is reproducible. But I like always very much to illustrate that with this tweet that says that, hey, you can download our code from this link. Good luck downloading the only postdoc that can get it to run. And I'm sure that many of you have gone through this situation where someone left the team and, oh God, what am I going to do with all this amazing data that I need to push forward, and I don't know how to make use of what this person did. So what happened since 300, 400 years ago? Well, it seems we are still using the PDF as our main tool for scholarship communication. And I like very much this resting paper information knowledge that the PDF entails, that was proposed by Son Binshofer, collaborator of a project, because most of what we put in a PDF is just the tip of the iceberg of a lot of things that are behind our research. And the reason why we are still there, I think, is because it's very complicated in practice, moving from these narratives, and the complete system of reproducibility, as I see it, would be that at some point we start defining the problem, we design the methodology, but before we really put our hands in the computer to describe this methodology, we would go to some digital repository and try to find something that can be usable for us. We can repropose it, we would be able to open and inspect it and then modify as needed and execute it on the same data or on different data. Then if we made some modification, we could again produce something that can be preserved and published, a whole research object, and put it again in this layer of methods that should be searchable. But indeed, it's not so easy. If we speak about big data, the access to the data, the raw data, is not very easy, depending on the amount of data. We have to produce catalogs that make the data and the images available, not only the PDF. The same happens to the code, and also the environment for the software needs to be preserved. And this is about following the FAIR principles. Oh, yes, and I think that there is some very specific aspect of astronomy, and is that we might think that it makes no sense to speak about reproducibility in astronomy because we cannot have in a control laboratory our research object, our subject of study, and especially in transient astronomy, where we have events that have a specific duration in time. So I refer you to the talk by Jacob Nordin, which will touch on this topic, as I have seen from the abstract. So I was saying that the FAIR principles are a bottom-up initiative to make our research findable, accessible, interoperable, and reusable. But the point is that the effort to achieve this is not always properly rewarded. And also we need new tools to support us in making our science fair. So speaking about rewards, I want to confront the metrics of research versus open science. I don't think the current metrics are good for making our science open, because we are killed by numerical ranking. Is not only said in this very same special of nature that I shown before. The fact is that it seems that we have to be productive, and this is more important than discovery. But also, it's very interesting to see that we are sensitive to rewards, to rankings. And that's a very, very fun example of a journal in which the authors were asked to share the data, and they did it at a very low level, 10% of the papers. But at some point, they started to offer those authors who were sharing the data badges, like this one, nothing else. And then the number of papers that were shared, the data that were shared, increased in this exponential way, as you can see. So it's interesting how we react to rewards. But we also are very used to putting our CVs the H index. We are asked to do that. It happens that you can go to a farm and forget about science, and your H index will keep increasing with age. So it's really a mild indicator of what we are doing. But also there are some studies that have already a good amount of years, but still very interesting, like a study made to try to see that if there was any correlation between the referee process and the impact measured by citations of papers. And after studying a very good number of papers, this project, Liquid Pub, found that there was very little correlation. And I'm not saying this means anything either against the referees or the citation, but it's just interesting. You can see it in the way you think is more suitable. And also another result was that in a project to measure how the reputation of an author impact the citation evolution of a paper, they found that if you are a very well-known person in the scientific community, the slope of your citation increases very quickly with respect to people who are less known. Not only that, but also the citations represent less than 1% of the usage of an article. This is just the usual citations, but there are the impact of research, as we will see also later when I speak about altmetrics, goes much much beyond that. And not only that, even if we care for the rest of ways to measure the impact of research, like looking at Twitter, that's another interesting result, is that this study about the life of giant pandas in some epoch of the Quaternary received a lot of tweets or interest in tweets, and this attention was attracted because there was this cute panda bear in the figures of the paper. So very difficult to assess the impact of research. And in summary, I think we have all heard about this publish or perish environment in which we are embedded. Probably you don't know, many of you don't know that this was said in 1942. And instead you can, in fact, you can find the book, The Academic Men, a study in the sociology of a profession. I don't think this book got old, and you can find it in a very famous web place to buy things. And another reflection is that we feel like if we open our research, we are giving advantage to our competitors. And also, as very wise people said, science improves through micro improvements, evolves through micro improvements. But when we look at our careers, if we see that we are doing only incremental improvements, we feel like this is not good for our career. So we become really paralyzed by this idea and stressed by this idea. So the caveat that was done by the science editor back in 2013 is that whether can excellence quotes kill science, because all these metrics make the fields of our fields of research move in directions where there is more people, because where there is more people working, you can have chances to get more citations. So that's a risk that was already considered in that time. And I said I was going to speak about economy, and you may say, what has economy to do with science? I like this definition, which I think is very telling. Economics is about understanding how we behave when resources are scarce. And the point is that this has in epoch of economic crisis, the candidates are pushed to get funds, but the funders also have trouble to get enough money to fund the experts during enough time for them to really do the required work. Because, and when I say the required work, I say this because when people is applying for some types of grants, they get kind of this advice, like the title of the project counts 50%, or that the proposals are, there's a practice to circulate proposals to a lot of people in the home institution. If they like the project, you are in a very good position to win the grant, to achieve the grant. And I think that this means, in other words, that evaluators are not thought to have time to read the proposals in details, or they are not experts in the field. And that's a bit sad. And I like these two examples. One is from many years ago, and there was in Facebook a company offering marketing for scientists. You still can find the book also. And it's interesting that this sentence that I'm not sure if you can read, it says, because sometimes unlocking the mysteries of the universe just isn't enough. What a pity. But like 1 week ago, I got this email to register for a tutorial saying that the skill of selling your idea to the founders is equally important to the design of the project. And the offer is to go to some training to develop winning proposals. So they are not telling me how to do science, they are telling me how to sell science. So economy and science are the cocktail for marketing. Another aspect in which economy is relevant is where it comes to publishing, as we all know. Open access means that you have to consider the cost and implications for your career. I have been told many times in my career by advisors to go to the most prestigious journal if I wanted to get a job. And And this plot shows that even this advice is not sufficiently good, because in the x-axis there is the fee to publish, and the y-axis is the influence of the article. And there is some correlation, but with a lot of dispersion between the influence of an article. And in fact, you can see that this is zero cost publications, and their impact can be really high, and as high as journals which are very expensive. But because we are in this system in which we pay so many times to publish, this says that this is the countries with more resources which set the trends in research. So what happens when we combine all these things? We come to this system of this academic prostitution, in which I think the fundamental idea here is that there is not a coincidence between what benefits science and what benefits the scientist, and then we have a real problem. And there are attitudes that show that, like people who pay other researchers, and that's true, to get their paper cited, to increase their H index. In some journals, you can give the email address of potential referees, and some people invented Gmail address for to propose referees who turn to be themselves. Or, you know, all these cases in the media of even ministers of education who were accused of plagiarism of their PhD work. But there is also the editorial system, because there is a bias against negative findings. Also, when there is a reduction, there is much less publicity. The main publicity goes to the positive result, not when there is a reduction. Also, some papers, some editors, some journals ask the authors to cite papers from this journal, so their impact factor is increased. And I don't get tired to quote Helmut Abt, who was for 28 years APJ editor-in-chief. And he was complaining that the policy of rejecting manuscript that receive too critical reports is a way to make sure that we don't really accept new ideas, and is innovation, is things that we question, where we want, what we should want to publish, because there is where we could have progress in science. And well, that was about the metrics and their effect in the system. But what are the tools in our hands in order to do reproducible science, open science? My first reflection, and this dates from 2013, I propose that we should shift the balance to the methodology. We shouldn't reward an exciting result, we should reward the quality of the result. If this is reproducible, this is science. And in fact, in astronomy, we are pioneer in this aspect. You know that the virtual observatory was established in 2002. It already started developing standards for to make the data fair, and also to develop ways in which people can publish the data. Anybody can publish the data, or anybody can develop virtual observatory tools. And even before the virtual observatory, the standard for the FITS format was defined in 1979, and there were access to other data archives in different places like the CDS. So, and virtual observatory is a reference for a case of study for the European Commission in turning fair into reality. And for the virtual observatory and reproducibility, I forward you to one of the talks in this conference, in this workshop. But I also wanted to expand the idea of what we should share. And this is about research object. A research object is a concept that was studied as part of an European project that finished in 2013. We coordinated the working package applied to the astronomy use case. And the main message is that in order to enable reproducible and transparent research, we need to expose the methodology. So we need to put together the publications, but also the data, the workflows, the slides, the metadata, and we should provide input and output examples so people can really follow what we did, annotations that can read by human or by machines, metadata for a large amount of things, including the execution environment, and also interoperability to favor discoverability and linked open data. Tools that I'm sure you know are Git and GitHub to share code. We need to not only share the code, but also make it understandable. And so for that, we have the open notebooks, which have this structure that I think astronomers like better, and is this Python notebook structure where we have the Python code and we can comment the code and see the figures at the same time, and also the scientific workflows, which goes through a more structured description and implementation of the research, and is very good for computationally intensive jobs on HPC. And I wanted just to give an example. You can go to this paper that is part of our research in galaxy evolution, Jones et al. In 2019. There is an appendix. The goal of this work was to study a complex compact group composed of several galaxies. This is an optical image. This is an atomic gas image from the VLA of the same group, where we see the gas linking the galaxies here and here. But in this paper, we made a very strong effort to make the paper end-to-end reproducible. And so you can you have a set of Python notebooks so that in one click you can reproduce all the plots and figures in the paper. We also paid attention to the repositories and all the other aspects of reproducibility. But this, for example, was something very useful for the first author, who is a postdoc, who was a bit worried about the time required to in order to make the paper reproducible. But when the referee came with the comments and he had to change the figures, he went to these notebooks and changed the parameters, and he could reproduce very quickly the figures of the paper. All this is explained in the paper, and I'm not going to speak more about tools because there are plenty of talks today and tomorrow, and I will just emphasize this one because it's the one I know better, because Javier Moldon is working as part of our team to develop an SK regional center. And I emphasize this one because I know he's going to speak about how, in order to respond to the SK data challenge, that he will explain what this is exactly, 29 reproducibility criteria were followed, and even we suggested some additional actions for this reproducibility checklist. So stay tuned for these talks. And other steps in research are the way to publish, not only the tools to do our sharing what we are doing in a wide way, but also there is the open access. As you know, I was going to say trend, but it's a policy. And in fact, there is a plan to get as many as possible publications in an open access way. I will not speak about the different ways of open access in a talk, it would be too long, but also not only open access journals, but repositories where you can put all kind of text, but also audios, videos, images, and display all the kind of results like Zenodo, where you can find in the first slide I've put the link to the talk that will be in Zenodo when I finish my presentation. And this slide, in fact, is from Rachel Ainsworth, all that you find here, and her talk is here. Very, very interesting talk. And I also like to speak about other publication models, web models, in which the expertise is not established based on authorities, but this authority, I mean, from the journals, but this authority is defined by the entire community, as the case of Math Overflow. There were also journals of negative results, as I said before, because these are usually not so much accepted by journals. And so these people said that they thought that these negative observations, if they were rigorous, then they were very useful for research. And we are very lucky because, and you might think what I'm saying, but this journal didn't publish after September 2017, but this is because there are a lot of journals now compared to that time that where you can publish your negative results. That's explained in this article. And so there is a lot of improvement in that sense. These are examples of journals where you are encouraged to publish negative results, but also in the case of Nature, there is also an editorial about the interest in publishing null and negative findings and recognized as vital for scientific progress. And I like very much this don't publish release, treat the research as software, from Carol Gobel, from which I learned so much about open science when we worked together in Workflows Forever project that I mentioned before. And in fact, the idea is that we do that already, but we sell it as we really have a very close and finished result in our paper. And we spend so much time finishing it and we delay it. At the end is intermediate steps to the next time when we have a better telescope or more data. So the idea is to really publish everything we get in an open way. And that ends this part of the talk. And now I'm moving to the situation that we are facing now is the big data science and whether it is possible without open science. I think the answer is no. And open science is not only an aim, is the mean to achieve extracting scientific knowledge from huge and complex data volumes, and also from these large collaborations in which we have to share and collaborate in an effective and efficient way. And not only to share to collaborate among human between researchers, but also we have to exploit in an efficient way DCIs and get tools to enhance this collaboration and making our science reproducible. And I put here the case of the square kilometer array, not only because I'm very familiar with this, but also because, as I said at the beginning, is going to be the largest generator of public data in the world. So at the end, the science of SKA, the core of the science is going to happen in the SKA regional centers. And this implies really a global shift in research practices, because it's not going to be possible anymore to transfer the data to the laptop of the scientists. And also, in order to facilitate these large collaborations, the development of the key science project. So SKA is getting ready in order to face these goals with collaboration with relevant institutions sharing the same concerns as in astronomy. But also developing these regional centers, and this scheme aims to represent the main ingredients that these data centers should have to support open science. In fact, the should is being transformed in will have, because we finished the phase of gathering initial requirements. And these regional centers should have transparent access for users to the data, but also to software to analyze and visualize the data. And this should be location agnostic, but also tools to enable collaborative science like workflows, provenance, and standards that allows interoperability, reproducible notebooks that are very useful not only to share the research, but also for user support and training. They are very good tools for training, and also to get open to society and enable citizen science. And all this requires new metrics of research. And here I want to make a kind of a parenthesis, because this complicated panorama that comes with these big data scientific infrastructures, astronomical infrastructures, implies that there are different roles that are involved in all this problem of how to achieve this. And this requires to take into account this new perspective. And I'm going to try to give this some hints of how these perspectives view the situation. In the case of the individual scientist that works directly on the his or her computer, this is about trust. We prefer to do things in our computer because in principle, we think we have the best code. I think we can say, I know how to use it. It can do special things that your code cannot do. I don't trust your pipeline because I'm better, but also because I have heard a talk about the reproducibility crisis. So how could I trust your code? And in fact, I can very hardly reproduce the result of my own papers some months or some years later. So in general, the user wants control of the environment, of the software and the environment. But then there is the view of the data centers, and the data centers have a problem because if every user wants to install their own software, they have to trust the software. They have to be able that it can run in the platform, and also might tell you, okay, we are offering services to the community. Can we share your code with other people with proper credit? And well, if we can, it's not enough that you put the software in the platform. We need, as we said before, the research object characteristics, the context for people to be able to reuse or repurpose your code. But now we have this large alliance of scientists, this large collaborations. And here I think the metrics of research careers is very, very important because these collaborations are developing tools to generate advanced data products. And they are going to probably put them in these data centers. And then they say data center, if the data center asks them to make this reusable, that's an extra effort. So while this alliance is doing that, are they facilitating things to competitors? And probably a frequent answer, and I got this one, is we need to wait like 3-4 years, which is the typical time for a PhD. So when the PhD is finished, you can have access to everything. And I must say that I'm looking forward to hear the talk of Gélé Desplat on how to make research accessible and reproducible in their institute in SRON. I'm really excited about knowing how it works. Then there's the publishers. Then if all these elements enter in the equation, we need different profiles of referees. We need maybe the referees to access the data centers to validate the paper. Do we have enough referees to do it? And we need to validate everything in a separate way, the data, the tools. And for that, I guess that Chris Lintott, in the talk after mine, is going to speak about the view from the publishers, a very refreshing view, I think. And also the policymakers are in trouble because how do we measure reproducibility and how we aggregate it with other indicators? And I will speak now about revised research assessments. But before that, I wanted to mention that there is also the view of the infrastructures. And for me, this should be becoming an exemplar. Because I think adopting open science is both a need, but a duty for infrastructures. And here I want to put the example of SKA that in the construction proposal that was approved last year by the council, the open science values are in reproducibility are among their foundational principles, but also the metric of the observatory is not only the number of papers and the citation, it's also the reproducibility of these papers. I would say, or to my knowledge, there is no facility that has included this as a metric of success before. So there is a full adherence to the FAIR principles. And the last part of my talk is about this revised assessment of research. I will go quickly through that. There are plenty of things, but the main thing to remember probably is that open science started bottom up with different manifestos, like the Metric Tide or the Lighting Manifesto. I will speak about Altmetrics and the DORA Declaration and Hong Kong Principles very briefly. Altmetrics means that there is a lot of material in which we can base the impact of our research. This was introduced in 2013. And I think a relevant idea is that the way we measure impact in academia now is beneficial for North America and Europe because of the resources we have. So is this dominant journals and topics of interest of this dominant scientific community that prevails over the others. So that's why taking into account other indicators that do not depend so much on resources are relevant. And so the idea is to gather impact, and it's not to replace, but aggregate different indicators of impact in YouTube. Many people after a conference upload a lot in the talk in YouTube. Now it's a general practice in conferences and different platforms to share the research. There's also the DORA Declaration. In this declaration from 2012, the community asked for a revision of the way we assess our careers. And then this was taken by the European community. These are different documents from 2017, 18, and 20 on, at the beginning, establishing groups in order to revise next generation metrics and how to consider altmetrics, and also the progress towards open science. And this is a very recent document from last November, in which from the European Commission again, in which the focus is on using quality assessment criteria, and whether if research is reproducible, then this would contribute to the quality of research, but also very important, recognize the diversity of research, the benefit of the diversity of research to science. And this is last slide of this part, and is that in the last in November's Council of the European Union, the future governance of the European research area was approved, and I emphasize here the reference to open science principles and the advance towards the reform of the assessment system for researchers and for institutions, and I think that's going to change the game a lot. But I like, I would say more this one because this comes from the community 1 year before, and this is the Hong Kong principles. There are 5 principles related with how to achieve research integrity, and the key ingredient here is open science and also diversity, as said in the other documents. And last, I would like to spend like 1-2 minutes on impact. The impact of doing open science, reproducible science is not only for our careers, it's for the planet. It's an approach to research that is collaborative, transparent, and accessible. So it's key for sustainability and inclusiveness. And the UNESCO said that is key to democratize the generation of knowledge and to hence allow the achievement of the Sustainable Development Goals of the United Nations. And a specific application of this to what we are speaking, I explained that in a talk about SKA and the Sustainable Development Goals, and how through open science those could be, some of them could be achieved, but I could say that the same for astronomy in general. And the main ones that we could mention is how relevant is open science to accelerate transfer of knowledge to society. And we know that after or during this pandemic's epoch, we need to speed up research, to share skills. This open science is very good to teach, for example, how to access public archives, to potentiate collaborative practices, but also in the goal for partnership for the goals, we need to allow this partnership to happen. And if science is hidden behind paywall barriers, that's impossible. So we need to promote exchange of ideas and avoid duplication. And also, apart from all previous reasons, it is useful for promoting equality and diversity and inclusion, because it allows to evaluate in an objective way the work, because it exposes the work and who perform it, and there where the hierarchies hide the work of mostly scientist woman, this could be exposed, and this would help them to trace their path in their careers. So, well, this is a summary that I think is worth just describing quickly, and you can go through it later if you want, because I think I'm a bit late. And the idea, this is the whole idea on how to connect the Sustainable Development Goals with open science. And the idea, the core of the idea is if we share methods and we make them more findable and accessible and avoid reinventing the wheel, scientific production is increased, knowledge is transferred more rapidly to society, make it reusable, and there is and that's important prompt the return of investment in big research infrastructures. At the same time, it promotes collaboration, because if we make the data and the software more understandable, it favors multidisciplinary collaboration, but also opens this to society, and then increases the trust in science, which is well needed and always important, because it also prevents pseudoscience. And all this has to come together with these new ways for science evaluation and open metrics. So my conclusions, I'm finished here, is that I take this from Chambers et al. I think that instead of playing the game, this is the time to change the rules, and that's what I think we are doing. Astronomy is very privileged or in a very good position, because we are pioneers in opening, and in open science is open reproducible science is both a duty and a need we have. But I also must say that when looking back to my first talks on the topic, like in 2013, I can see we made a lot of progress in all areas. And at the end, I think that there should not be good science, but only science that follows the scientific method. And that's it. Thank you.
Okay, thank you, Lourdes, for this very cool talk. So we have 5 or 6 minutes for questions. So we have at least one already that I can pass along to you in Slack. If people could write their question in Slack, then I will read it out for the speakers. So we have a question from Sasha, which was actually one that I was going to ask as well. She says that the example where the journals handed out badges for reproducibility was very cool. She was wondering if other journals followed that example after people saw that effect.
I don't know the answer for that. I'm sorry. I hope not, because it wouldn't be the true reason to motivate people. But I must say I don't know. I just found this when preparing a previous talk, and I found it really shocking. I must say. How humans we are human beings. This is very interesting. But no, sorry, I cannot tell. I look right. We finish. When I finish, I will look at this.
Cool, thank you. So I can see several people typing questions while they're typing to give time. Oh, someone just finished. So we have a question. I'm afraid I don't know how to pronounce your name correctly, so I won't try. I'm going to embarrass myself. The question is, you have some very fascinating ideas on open science and things that should be done to make open and fair metric recognized. My question is, who gets to make the decision to accept these recommendations, and how do we get through to those individuals?
Yes, well, very good question. Well, this is a combination of bottom-up and top-down. That's very clear. That's why I wanted to put the timeline for the proposal of this re-evaluation of the how we assess people's careers, how we value the CVs, and I think it has to come from both ends, because at the beginning, Altmetrics was kind of a freaky thing that people in the institutions didn't appreciate. In general, open science was like that, and then the different manifestos from different communities reached. I know better the case in Europe, so it reached the European Commission, and they decided to first propose these studies, and then started to understand that this was relevant. And there is all this back and forth between the community and the evaluators. And I would like to put a small example of a way in which we can influence these decisions. And is when someone, maybe a postdoc, applies for a job and has kind of a form to present the CV, some template. Why don't you include there also what you think the evaluator should read, not only what they ask for? Let's train the evaluators. Let's not wait for the evaluators to learn. Let's train the evaluators, because I think that I've been in committees when I find in a CV something unusual, like my software was downloaded by industry, and this person puts like just one line, but it says that there was 2,000 downloads from different companies, because this person could track who downloaded the code. That's something interesting. That's about transfer of technology to industry. And it's not only about patents, it's about other things. So if we can do it bottom up, not only top down. And I think this example is something I would like to encourage young people to do, and is train the evaluators.
Cool. I like the sound of that approach. So I'll just ask one more question. This one's from Talis Pessi, who asked if you could talk a little bit more about the don't publish, share policy that you mentioned briefly in your talk.
Yes, not sure if this was the don't publish release. Is this the same, Talis? Because I think that's what I said. I think it's release, and the idea is that, and there are journals already doing that, you don't have to present the final result of your research. You have to present where you are. So you present your approach, and you may not understand why your method produced such result, but it worked. Then you are allowed to publish this. And then someone else can come and follow this, or you can publish a second version. So it's exactly the same idea as software. Software is never finished. You always want to improve something. You add some patch, you add some functionality. Research is the same. Just we don't accept that. We have these egos that say that we have to have a big, nice result finished to be able to publish. So we have a press release, and I mean, that's the system. I don't think that mean everything is bad in the system. And at the end, we all also play the games. I must confess that. But I think that if we accept that going incremental is good for science, if we can accept that, we can value the people who is really providing the ladders, the different ladders for us to arrive to the next point. No? Like we know this in big words, like in Shoulders of Giants and Newton and the Stephen Hawking's book, I think, but it can be applied to a small scale. I don't know if this is what you wanted to hear.
Cool, thank you very much. So if anyone has more questions for Lourdes, please write them in Slack. And if Lourdes, you would be so good as to give people answers on Slack as well, that would be